Hi, this is a video about arbitrary roots as opposed to just roots that you normally think of. So say we want to take the square root of 16. Remember, by default there's a 2 up here. If you don't see anything else, it's a 2. So the square root of 16 is what times what equals 16. We start off with our 16 number, and we go to our list of prime numbers. 16 is divisible by 2, so we put 2 into 16 and we get 8. 8 is divisible by 2, so we put 2 into 8, we get 4. 4 is divisible by 2, and you end up with a remainder of 2. So if we take 16, the square root, and we write it like this, we can get 2 times 2 times 2 times 2. Because it's a square, a second root, any groups of 2 we can pull out. So we can pull out from this group here and this group here. So we'd get 2 times 2 out from underneath the square root equals 4. And sure enough, 4 times 4 is 16. So let's try a cube root. Let's try the cube root of 27. If there's going to be a cube root, because 2 is the default, you have to change up here and put in the 3. So what a cube root is what times what times what equals your number. So we do the same thing. We put 27 over here. Will 2 divide into 27 evenly? No. If you divide 27 by 2, you get 14.5. So you can't use that prime number, you go to the next one. Will 3 go into 27? Yes, 3 goes in there, 9. 3 goes into 9, 3. So you can rewrite this as 3 times 3 times 3. Now, because that is a cube root and 3, that means to pull something out from under, you need 3 of them. Well, we have 3 3's, so we can pull out a 3. So the cube root of 27 is 3, or 3 times 3 times 3 equals 27. Let's try a bigger number, the cube root of 216. Again, that means what times what times what equals 216. So we start off the same way. We put 216 and we divide by the smallest prime number we can. It is divisible by 2. We know that because it's an even number. So we put our 2 there and we get 108. Again, it's an even number, divisible by 2. We get 54. Again, an even number, divisible by 2. We get 27. 27 is not divisible by 2, so we have to go down to 3. 3 goes into 27, 9. 3 goes into 9, 3. So, if we were to rewrite that, we would have 2 times 2 times 2 times 3 times 3 times 3. Remember, we're working with cube roots, so we need 3. We got a group of 3 here, a group of 3 here. So we can pull out that 2 here, 2. We can pull out this 3 here, 2 times 3. So we get 6. The cube root of 216 is 6. So 6 times 6 times 6 equals 216. So let's try a fifth order root. A fifth order root is what times itself 5 times equals our number. So, as before, we put our number here. We know that this number is not divisible by 2 because it's odd. We know that if we divide it by 3, the next prime number, it doesn't work out. And there's a little trick you can tell, because if you add up these numbers, you get 3 plus 1 is 4, 5, 6, 7, 8, 9, 10, 11, and 11 isn't divisible by 3 either. So we know that our first prime number that it works is 5. And that gives us 625. So, again, 625, the lowest one it will work is 125. And then again, 5 will go into there, 25, 5, 5. So underneath our 5 root, 325 is 5 times 5 times 5 times 5 times 5. We have a 5 there. We need 5 to pull it out. 1, 2, 3, 4, 5. We can pull it out. And the 5th root of 325 is 5. So what if our number just doesn't work right? Let's try the square root of 48. Again, what times itself equals 48? We know that 48 is divisible by 2, gives us 24. 24 is divisible by 2, gives us 12. 2 goes in there 6. 2 goes in there 3. Okay, so we have here 2 times 2 times 2 times 2 times 3. It's a square root, a second, so we know we can have groups of 2, and we can pull those out. We get 2 times 2, or 4, but we're still left with the 3 under the square root sign. We know that the 4 is multiplied by it. The answer we would call 4 radical 3, but what if you want a decimal number for that? Well, if you want a decimal number, luckily we have calculators and they've been figured out. You can keep going on and trying by hand what times what equals it, but the square root of 3 is 1.73. So in our prior one, we had 4 radical 3, and that would translate to 4 times 1.73, which my handy-dandy calculator says is 6.92. We try 6.92 times 6.92, like that, you end up getting 47.89, which rounds up to 48, which is close to where we were. And that's how you do arbitrary roots.